Hi, my name is Oktay. Today's video is about the chemical element gold. Its name comes from the Latin word aurum, symbol Au. In nature there is just one single isotope, that's 197. The atomic number is 79. So it means it has 79 protons, 79 electrons, and 118 neutrons. This is a typical phenomenon with heavy elements. They have many more neutrons than protons. Neutrons are glue for the core, nuclear core, and for the heavy elements you need more neutrons. Melting point is 1064 degrees Celsius, and the density is 70% higher than that of lead. This picture shows where the gold comes from. Here is gold. It comes from very extreme conditions during the merging of neutron stars. This shows you the abundance of the chemical elements in the Earth's crust. Gold is here, low end. It's just at about 2 to 3 parts per billion. Gold has a relativistic effect. It has 14 4f electrons. They are on eccentric orbits. They can't shield the nucleus very well. Plus it has a 6s1 electron, a single electron on a spherical orbit. This electron orbit experiences a strong attraction from the nucleus. That's why its orbital is contracted. That's why there's a relativistic effect. This electron has a speed of 58% of the speed of light, which is about 174,000 kilometers per second. And that makes gold a very noble metal. And not only the orbitals, but also the energy levels are contracted. And so much so that gold can absorb parts of the visible blue light. And this gives gold its golden color, because yellow is the complementary color to blue. This is a picture from a gold mine. And there's an indicator for gold, that's quartz, SiO2. About 2,500 to 3,000 tons of gold are mined per year. The ore typically contains around 1 gram of gold. Top producers are China, Russia, and Australia. And this is how you can isolate the gold from the ore. Gold is oxidated in presence of cyanide. This gives you the stable complex gold dicyanoaurate complex. And the reduction with zinc gives you back gold. And cyanide is very toxic. You have to make sure that this reaction is a basic medium. And you can neutralize the cyanide with Karat acid, that's H2SO5. This gives you the less dangerous cyanide, OCN-. This picture, the left picture, shows you a fool's gold, pyrite, FeS2, but iron disulfide. And for comparison, at the right, you have the gold nugget from the National Museum of Natural History in USA. It is about 15 centimeters long. These are properties of gold. It is resistant to most chemicals. It's a very malleable metal. It has the third highest conductivity behind silver and copper. Number 4 is aluminum. It is very ductile. You can make thin wires, and it is not toxic. This picture shows you the gold reserves of all the rich countries. You can see USA has about 25% with over 8,000 tons. Germany 10%, France 7%, Italy 7%. And gold supports the national currency. These are the applications of gold. You can use it for jewelry, for electronics. For electronics, you make again use of the fact that it's a noble metal. It doesn't corrode, and it's a very good conductor. That's why it's interesting for the connectors. and you can make colored glass, and it's used for tooth restoration. There's a radioactive isotope of gold, that's gold 198. You can use the beta decay of this isotope for cancer treatment. Gold nanoparticles can also be used for cancer treatment by exposing them to light or radiation. The nanoparticles absorb the heat, and excessive heat kills the cancer cell. Since gold is very malleable, you can make gold leaf with a thickness down to 0.1 micrometers, and these leaves are used for art and architecture. Yeah, some people don't like the yellowish color of gold. They prefer white gold, and white gold is gold alloy with silver or nickel or platinum or palladium. The purity of gold is measured in Karat. The Karat name comes from the Arabic Karat, and pure gold has 24 karat, and there are all these different concentrations down to 14 karat, which is about 58% gold. In the 3rd century before Christ, Archimedes was ordered by his king to find out if his crown was pure gold or not. And while he was taking a bath, he recognized that displaced water as he entered the bath, and that gave him the idea how to measure the pureness of the crown by measuring the volume of the displaced water. The mass divided by the volume gives you the density, and with this method he was able to prove that the crown was not pure gold, it contained silver. And according to the story, when he had this idea, he had this eureka moment, and he ran outside and yelled eureka, but he forgot to put on his clothes. This is the James Webb Space Telescope. Its mirror is coated with gold. That's for infrared light. And this is the plaque of the Pioneer 10 and 11 spacecrafts. The idea for this plaque came from Eric Burgess, and together with Carl Sagan and Frank Drake, they made it happen. These are gold anodized aluminum plaques. They were put on the Pioneer spacecrafts. They are on the way out of the solar system. And this plaque contains enough information for an intelligent being to determine our position in the Milky Way, because it shows the sun's relative position to the Milky Way center and to 14 pulsars. And this is a visiting card of humanity. That was today's video about gold. Thank you for watching. Have a nice day. Bye-bye.